Good morning friends, welcome back to Panika Tutorials. In this video, I want to discuss one of the UGC NET question which came in the year 2018 related to round robin scheduling algorithm. This kind of questions will help you to understand the concept in a better way. So I request everyone to watch the complete video for better understanding. First let me read out the question, then I will discuss the solution with you. Look at the question. Consider the set of process and the length of CPU burst time given in milliseconds. They have given 4 processes such as P1, P2, P3, P4 and the CPU burst time they have given in milliseconds as 5, 7, 6, 4 respectively. They have not provided the arrival time. Assume that process being scheduled using round robin with time quantum as 4 milliseconds. Then the waiting time of process P4 is, they have given 4 options. Option A is 0, option B is 4, option C is 12, option D is 6. So we need to solve the question and find out what is the right answer. If you look at, they have not given the arrival time. In the question, if they does not give the arrival time, you can consider it as 0. Okay, at 0 milliseconds, all the 4 processes arrived, but the arrival order is first process P1, then process P2, then process P3, process P4. Okay, now they are asking about the waiting time of process P4 and the scheduling algorithm is round robin. Okay, so it is a round robin scheduling algorithm with time quantum as 4 units. In the round robin scheduling algorithm, the time quantum is one of the important parameter. So they have given the time quantum as 4 milliseconds. Okay, now we will solve the question. To do that one, we need to draw the Gantt chart. Okay, for any scheduling algorithm, the Gantt chart, if you can draw, then the solution is done. Okay, now to discuss this question, let me discuss the ready queue and the running. Okay, ready queue and the running state. Is it clear? Now look at here. At the 0 milliseconds, okay, always the Gantt chart will start from 0 units of time. Here the units of time is milliseconds, so I am considering it as 0 milliseconds. At 0 milliseconds, what are the processes which are there in the ready queue? There are 4 processes because all the 4 processes arrived at 0 milliseconds and the order of arrival is P1, then P2, then P3, then P4. Okay, so as the process P1 has arrived first, it will be dispatched to the running state. Okay, process P1 is in the running state at 0 milliseconds. And look at its burst time, 5 milliseconds it is required the CPU to complete its task. But as it is a round robin scheduling algorithm and the time quantum they have given us 4 milliseconds, so even the process P1 needs 5 milliseconds of CPU time. It will be provided only 4 milliseconds, then it will be sent back to the running state, ready state. Is it clear? Okay, are you able to understand it or not? So process P1 is done. Then the next process which is there in the ready queue is the process P2 will be sent to the running state. Okay, now process P2 requires 7 units of CPU time. You can write it. Process P1 needs 1 more unit of CPU time to complete its task. Process P2 needs 7 milliseconds of CPU time to complete its task. But as the time quantum is 4 units, it will run up to 8 units and will be sent back to the ready queue. Is it clear? So process P2 is also done. Now process P3 will be sent to the running state. Okay, process P3 needs 6 milliseconds of CPU time to complete its task, but the time quantum is 4 milliseconds, so it will be provided only 4 milliseconds and it needs 2 more milliseconds to complete its task. Again it will be sent to the ready queue. Okay, is it clear? Are you able to understand? Now process P4 will be sent to the running state. Okay, process P4 needs 4 milliseconds of CPU time and time quantum is also 4 milliseconds, so it will be run and its remaining time is 0 milliseconds. So it has completed its task. Once the process is completed its task, it will go to the terminated state. So process P4 will not go back to the ready queue. Is it clear? Are you able to understand? Now look at here. Process P1 is there in the queue next. So process P1 will be dispatched to the running state. And how many units it requires, or how many milliseconds it requires of CPU? 1 millisecond. Even the time quantum is 4 millisecond. It will run for 1 millisecond and will go to the terminated state. Is it clear? Once the process has completed its task, it will go to the terminated state. So process P1 is done. Then next process P2 is there. It will come to the running state. Okay, it needs CPU 3 units. Even the time quantum is 4 millisecond. It will run for 3 milliseconds and it will go to the terminated state. Then process P3 will come to the running state and it needs 2 milliseconds of CPU time, and it will be given. Once it is done, it will go to the terminated state. So all the process P1, P2, P3, P4 as completed by 22 milliseconds. If you have a doubt, you can check. 5 plus 7 is 12, 12 plus 6 is 18, 18 plus 4 is 22. So burst time of all the process, if you combine, it will be 22. So at 22 milliseconds, all the 4 processes completed. Now we need to compute the waiting time of process P4. To do that one, we need to find the completion time, turnaround time of each process. First, let me compute the completion time of each process. Okay, process P1, process P2, process P3, process P4. When the process P1 is completed at 17 milliseconds, process P2 at 20, process P3 22, process P4 has completed at 16 milliseconds. So we got the completion time. If you have a doubt, you can check it. P4 at 16, okay, P1 17, P2 20, P3 22. So the need for the Gantt chart is completed. Now we can erase it. Now let me compute the turnaround time of each process. Turnaround time is equal to completion time minus arrival time. Okay, now look at here. Completion time is 17 milliseconds and arrival time is 0 milliseconds. So 17 minus 0 is 17, 20 minus 0 is 20, 22 minus 0 is 22, and 16 minus 0 is 16. Now we need to compute the waiting time of each process. Okay, waiting time is equal to turnaround time minus burst time. So 17 minus 5 is 12, 20 minus 7 is 13, 26 minus 6 is 16, 16 minus 4 is 12. So we got the waiting time of each process. What is they are asking? Waiting time of process P4, which is 12. So option A is 0 is wrong. Option B 4 is wrong. Option C 12 is right. Option D 6 is wrong. So for this question, the right answer is option C. I hope you have understood how I solve this question. If you still have any doubts related to the round robin scheduling algorithm or related to this question, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.